Good afternoon, everyone. Am I audible? Yes. Am I audible? So can we start with that?
Yes, sir. Yes, sir.
Yes. Okay, fine. Sure. Good afternoon, everyone. And today we'll be starting with integration. So here we go about with integration part. Okay, so miscellaneous exercise. Now, basic thing that here again to find the values of the fill in the blanks or true or false or the correct answers, objective questions, multiple choice questions, you need to solve integration, right? There is no shortcut as such that you will get the answer straight away. But if you practice a lot, you will understand that what are the answers without solving that part, right? So let's start with the integration part, miscellaneous exercise 5. Now, if you don't understand any of the MCQs while I'm teaching, then please let me know that time only. Okay, at least for the objective types of question, multiple choice questions, right? True or false and fill in the blanks we can solve at the end also. That's not a problem. So we start with the first question. The question goes as, find the value of integration 1 upon root 1 minus x. So we know that it is nothing but integration of 1 minus x raised to minus half, right? We can apply this formula. We take law of indices in the raised to power. So that becomes raised to minus half. And then we apply the integral formula. So this is integral formula. 1 minus x raised to minus half plus 1 upon minus half plus 1. But remember that this is a chain rule part of the sum, right? This is your f of x raised to minus half part. There is something extra along with x. So the rule says that whatever is x ka coefficient, that goes in denominator. So your x ka coefficient is minus 1. So we write minus 1 in the denominator with the ending part as plus c. Constant of integration is very important for all the indefinite type of questions. We simplify this sum, we will get 1 minus x raised to half upon minus half plus c, and that will become minus 2 root 1 minus x plus c, which is nothing but option A. So answer for the first one goes as option A, 2 root 1 minus x with a negative sign. I'm so sorry, with a negative sign we have. So answer will change to option B, minus 2. Right? So you'll have this value as the part of the first answer, minus 2 root of 1 minus x plus c. Okay, second one, root of 1 minus x square. Now this is our direct formula, under root of a square minus x square. Okay, which is given by the formula x by 2 under root of a square minus x square plus a square by 2 log mod x plus root of a square minus x square plus c. Right? So this will be your answer for that particular thing. This is a direct formula. Right? Now, what's the difference here? If you understand, I may have written this as root of 1 minus x square. This will be 1 minus x square in the brackets. Right? So your answer will be direct formula option A. X upon 2 under root of 1 minus x square plus a square. Here a square is nothing but 1 square. So 1 by 2 log mod x plus given question. So your answer for the second one becomes A. So first one was B, second one was A. I think so the question was root 1 plus x square. If it is root 1 plus x square, everywhere you will have a plus sign. Right? So as per depending on the question, if it is a plus, everything will be plus part. Right? So you will have this part as your answer. Okay, first and the second one, option B and option A. So second one is the direct formula. First one was chain rule of integration. We divide the entire answer with the coefficient of x. Sir, can we use chain rule in the second one? Like for example, can we write 1 plus x square raised to half, and then we apply something like this, half plus 1 upon 1 and something like this? No. The rule of integration says that chain rule is applicable only when the degree of x is 1. Means x should be having raised to power as 1 only. If it is x square, that I cannot apply the chain rule. So I cannot write this divided by 2x. No. Right? So this is the basic rule of integration for any of the exercise you solve. The degree of x, if it is raised to power as 1, then you can apply the chain rule. Yes. Sir, can you please repeat the first one? Yes, why not? First one, here we go. Right? I have written root as half. That half goes in the numerator, it becomes minus half. And then we apply x raised to n formula. So that becomes x raised to n plus 1 upon n plus 1. But since here we don't have x, we have f of x, right? We have a composite function. So we take the derivative of the composite function. Now, logically, it is nothing but derivative, no, but we are taking about the coefficient of x. So the coefficient of x is minus 1, so that goes in denominator. So this is the expanded part. And then we simplify the sum and we get the answer as option B. Right? Are we clear with this? Can we move on to the next one? Okay. So we go on to question number 3. Okay. X square into 3 raised to x cube. We have to find this integration, right? Okay. So now here we'll take the help of substitution. Now, what is the rule of substitution? You take that term as t whose derivative is available in the question and which can go along with dx and become dt. Again, I repeat. You take that term as t whose derivative is available in the question and that goes away along with dx to become dt. So here I can take x cube as t. So derivative of that will become 3x square dx is equal to dt. Okay. If we don't write directly, we write this as dt by dx. Out of that, I have x square and dx in my question. So x square and dx will become dt with 1 by 3. So my new question will look something like this. 1 by 3 integral of 3 raised to t dt. We know that 3 raised to t is nothing but a raised to x formula. So that will become I is equal to 1 by 3 a raised to x upon log a plus c. In the last step, we have to resubstitute. So t will be replaced by x cube again. So we'll have 1 by 3 into 3 raised to x cube upon log 3 plus c, which is nothing but option B. Right? So here my substitution goes as x cube is equal to t. Right? Now, if someone says that, sir, I want to substitute 3x cube as t, that is also okay. Still, you will get the final answer, which is same. Right? So it doesn't matter whether you take 3x cube in this case or x cube only, the final answer will remain same. Question number 4. X plus 2 upon 2x square plus 6x plus 5 is equal to, and they have separated the question into 2 parts. Right? Now, what is this 2 part? This is nothing but of the type CS, which is nothing but, in our terms, completing the square. So this is completing the square where we find the derivative of denominator and adjust the numerator accordingly. So the derivative of denominator will be what? So derivative of denominator will be 2x square plus 6x plus 5 is equal to 4x plus 6. Right? 4x plus 6. My original question is x plus 2. So first I need to understand that I will be writing x and I will be converting x into 4x. So my first step will be I multiply and divide by 4. So I will have 1 by 4, 4x plus 8. Because that 2 will also get multiplied by that value. So 4x plus 8 divided by the denominator. Now I want 4x plus 6. I have 4x plus 8 in the numerator. So I will split 8 into two parts. So I will have 1 by 4, 4x plus 6 upon denominator plus 1 by 4, 8, sorry, 1 by 4, 2 upon denominator. So I have splitted 6 and 2. The 8 is splitted as 6 and 2. Sir, how did you come to know we have to split that into 4x plus 6 and 2 only? Because we need to first adjust the derivative of denominator in the numerator. So 4x plus 6, you got that part. And the second part, if you see from the given question, this 2 and this will get cancelled. This matches with my this question. And this matches with my question, left hand side first part or right hand side first part. Therefore, I can say that the value of P is nothing but 1 by 4. Okay, so the value of P is nothing but option C, 1 by 4. Please take a look at this sum. If you have still some doubt in this, please do ask me. Right? Again, I repeat the steps.
Please explain this again.
Sorry, Veer.
So could you please explain this again?
Yes, Veer, I'm doing that part. Okay. So what we are doing here is we are using completing the square. Right? Now, whatever you have solved in the exercise of completing the square, that was linear upon quadratic or maybe 1 upon quadratic, only that type of question. Now, this is one of the examples which you can see while solving the solved examples. Okay. So please understand solved examples are also important. Go through those questions so that you understand this type of sums also. So here the rule says that if your numerator is not 1, if the numerator is not 1 and it is a function of x or it is a type of something with x in the numerator, step number 1 says that you take the derivative of denominator, adjust the numerator accordingly. So I take the derivative of denominator, which comes as 4x plus 6. Now out of that 4x plus 6, first I have to bring into the question the value 4. So that is the reason I multiplied and divided by 4. Now, once I multiply and divide by 4, the 2 also changes. So 2 changes to 8. But I wanted 4x plus 6. So the 8 is split into two parts. One was 6 and the other one was 2. And based on that, I compare the value of P and I get that P is nothing but 1 by 4. Right, Veer? I am clear about that part. Everyone understood this question number 4? Okay. We go on to the next question. Question number 5. So the answers here were B and C, third question, and the fourth question respectively. Question number 5. X minus x squared, right? Now looking at the sum, it becomes like, oh, it will be something like a quadratic hai, so I can use completing the square, or I can find using partial fraction. Your choice, right? It is absolutely your choice. Your answer will match one of the options given here. Right? So how do we start with this question? So we write this as integration 1 upon x into 1 minus x. Right? 1 upon x into 1 minus x. So you are doing completing the square. You can find the last term, add, subtract, and complete the square. If you are doing partial fraction, you can do this way. You can write this as a upon x plus b upon 1 minus x. Or you can just write this thing as bringing the denominator same as whatever is in the denominator, same to same in the numerator. So how can I bring that part? So I can write this as 1 minus x plus x. Please understand what I have done is I added x and I subtracted x. I had only numerator में 1. 1 is still there. I added x, I subtracted x. So why did you do this addition of x and subtraction of x? So that in the next step, I can separate my numerator. So when I separate my numerator, the first term will be 1 minus x, x into 1 minus x. The second term will be x upon x into 1 minus x. What gets cancelled? So your 1 minus x gets cancelled, your x gets cancelled. What will be 1 upon x ka integration? It will be log mod x plus. What will be 1 minus x integral part? It will be log mod 1 minus x, but remember the chain rule. Here it is not x, it is 1 minus x. So whatever is the coefficient of x, that goes in denominator. So you will have log mod x minus log mod 1 minus x plus c. Now they have not used any of the properties of logarithm. So this is what I get from option A, log x minus log mod 1 minus x plus c. So any which method you apply, you need to simplify till you reach this final step. Right? So that is question number 5. We go on to question number 6. X minus 8, x plus 7. Okay, that is the given question. X minus 8, x plus 7. All right, so how can we go about with this? So we can use partial fraction, right? So I will be writing this as 1 upon, okay, I will start on a new page so that we understand this. So we'll be having this question here. Okay. So the question was integration of x minus 8, x plus 7. So I will write here integration of x minus 8, x plus 7. Right? If you open the brackets, it will become a quadratic equation, and then you can use partial, you can use completing the square. That's all fine. So here we'll have 1 upon x minus 8, x plus 7 is equal to a upon x minus 8, b upon x plus 7. We cross multiply or we take LCM, whatever you say, bx minus 8 will be there. Now to get the value of a, we substitute x is equal to 8. To get the value of b, we substitute x is equal to minus 7. So when I substitute 8 in this, it will be 1 is equal to 15a. So the value of a comes as 1 by 15. When I get this minus 7, so it will be 1 is equal to minus 7 minus 8 minus 15b. So b is equal to minus 1 by 50. We have both a and b with us, so we can now make the integral part. So we'll have integral of 1 by 15, 1 upon x minus 8, minus 1 by 15, 1 upon x plus 7. And then we apply the formula of log mod x minus 8 minus log mod x plus 7. I've taken 1 by 15 common. And then since we want something upon something as per the given option, this will be the part x minus 8, x plus 7 plus c. So 1 by 15 log mod x minus 8, x plus 7 plus c. And I think so that's our option number C, right? Now, logically, if you think, I wouldn't have solved the sum only, right? Because I know that my answer has to be in terms of log, and it has to be in terms of log A upon B, something like that. Option A cannot be my answer because the factors are only different, right? So I cannot have this answer, that is for sure. Option B also cannot be my answer because one term is x minus 8, the other term is x plus 7. Here, both terms are in positive. So B also goes away. D can't be my answer because this is a quadratic equation if I open the brackets. And we have 1 upon something, so answer has to be in log. So logically, if you understand, I would haven't solved the sum at all. My answer straight away was option C beforehand only, right? But I needed to make you understand how do we solve this. So this is the method of solving partial fraction. A upon plus B upon, and then we take the values and get A and B's values, and then we find the integral part. Right, I hope you understood this question easily. That was a very easy question. Option A and option C were the answers for the 5th and the 6th one. We go on to the next one, question number 7. X plus 1 upon x the whole cube. Now this becomes difficult if you do not know A plus B the whole cube, which I am very sure that you know this part, right? Just recollect that and tell to yourself what is A plus B the whole cube, right? So it is nothing but a cube plus 3a square b plus 3ab square plus b cube. Right? So this is what we have, a plus b the whole cube. This means that my final answer, whatever it comes, should be 4 terms plus c, constant of integration. Well, total my answer of the options should have 5 terms. which means that my option A is not a proper answer because I cannot use this part, because you will say, sir, x ka degree to 1 hai. It is not 1. 1 upon x means it goes up, it becomes x raised to minus 1. Right? So degree is not 1, degree becomes minus 1, and then I cannot apply my chain rule. Right? So option A cancels out. Option D is not my answer because option D is also not possible. What they have done is they have just written the question and changed the sign of plus with a minus sign. So my answer logically has to be option B or option C, right? And the difference between option B and option C is only the last term, that is the term before constant of integration, okay, which is B cube, which means that 1 upon x the whole cube. I will expand, I will get 1 upon x cube as the last term. If I'm doing the integration of that, it will be x raised to minus 3, which will be equal to x raised to minus 2 upon minus 2 plus c, which can be further written as minus 1 by 2x squared plus c. So now option C also gets cancelled. Option B becomes my final answer. Right? I'll show you the entire sum also. I will expand it. I'll show you the entire sum. How does it matches entire option B? But you have to be very smart. Don't expand all the things. Whatever is different, you just check that part. Okay, so I expand this part now. I'll solve it logically. How do we get? So x cube plus 3x square 1 upon x plus 3x 1 by x square plus 1 by x cube. We are finding integration of this part. X cube will be x raised to 4 upon 4. 1x gets cancelled, so it will be 3x square upon 2 plus 1x gets cancelled. 1 upon x is log mod x. And the last term we have already solved up, minus 1 by 2x squared plus c. Right? So logically your answer will be option B, which we have already solved. Right? Question number 8. E raised to 2x, e raised to minus 2x upon e raised to x. So first step is we split the question into two parts, separate the numerators. E raised to 2x upon e raised to x, e raised to minus 2x upon e raised to x. The first part, 1 e raised to x gets cancelled. In the second part, law of indices, it gets added. So that becomes minus 3x. We know that the easiest formula in integration is of e raised to x. It remains as it is. E raised to minus 3x will give you e raised to minus 3x upon minus 3, chain rule. So why did we use chain rule here? Because again, I repeat, it is not e raised to x, it is e raised to f of x. And the degree of x is 1 here, so we can use this chain rule. And then we rearrange this question. So we check as per the options. The first term has to be e raised to x positive. So option C and option D gets eliminated because e raised to minus x is not our answer. And in the A and the B option, what is difference? It is only the minus and the plus sign of the second term. So here we want a minus sign because we have minus 3 in the denominator. Option A will be our answer in this case. Yes, Riva. Okay. Right? Are we clear with this? So question number 8, option A becomes my answer. So 7th was option B, 8th was option A. We go on to the next one, question number 9. 1 minus x raised to minus 2. Right? So 1 minus x raised to minus 2. Direct we can apply x raised to n formula. 1 minus x raised to minus 2 plus 1 upon minus 2 plus 1. And the chain rule, the coefficient of x is minus 1. So that will give you 1 minus x raised to minus 1. Minus 2 plus 1 will give you negative 1 into negative 1, which is 1. So our answer, final step will be 1 minus x raised to minus 1 plus c. Right? So this will be your answer for the question number 9. Question number 10. Right? It looks very difficult sum because we have x cube, 3x square, and so on. And denominator is raised to 5. Right? So first look tells us that it becomes a very difficult sum. But the second step becomes very easy if you understand the numerator is a plus b the whole cube. Which means numerator can be written as x plus 1 the whole cube. And you can expand and you can check. x cube plus 3x square plus 3x plus 1 cube, which is 1. Divide by x plus 1 raised to 5. So simple sum it becomes 3 minus 5 will give you minus 2. And this is same as the sum which we have done in question number 9. It will be x plus 1 raised to minus 1 upon minus 1 plus c. Minus 1 upon x plus 1 plus c. Option A. Right. So the sum looks difficult, but is easy if you understand the first step properly. Right. So we have applied a plus b the whole cube, and this is what we have in question number 10. I hope you understood the questions of the multiple choice question. Choose the correct alternatives. All the 10 questions done. We move on to the next one. Fill in the blanks. As I said, you would not be able to understand orally all the questions. Few questions you can understand orally, but all the questions require a solution, or we need to write it in a rough so that we get an answer which is proper and correct. So the first one, 5 into x raised to 6 plus 1 upon x square plus 1 is equal to this, right? And the red part is nothing but the fill in the blanks, which we wanted to calculate. Now, how do we solve this? So first step is I can write x raised to 6 as x square the cube plus 1 upon x square plus 1. Then I can apply a cube plus b cube formula. So that will be a plus b, right? I'll just write the formula. A cube plus b cube is equal to a plus b, a square minus ab plus b square. Right? This is the formula. Don't apply the a cube, a plus b the whole cube formula, else you will end up doing something else only. So this will be x square. So this will become x raised to 4 minus x square plus 1. The whole divided by x square plus 1. X square plus 1 gets cancelled. Right? So x square plus 1 gets cancelled. So you will get 5 integration of x raised to 4 minus x square plus 1 dx. We know the integration of x raised to 4 will be x raised to 5 upon 5 minus x cube upon 3 plus x plus c. And when we open the brackets, every term will get 5. So first 5 gets cancelled. Next we have 5 upon 3x cube plus 5x plus c. Right? So your answer in this question becomes minus 5 upon 3. You need to understand that you cannot get this orally unless and until you have learned these things, then, right? And which I am against it, that don't learn these things, try to understand. It will be easier for you to get it in the exam. So that was the first question. We move on to the next one. Question number 2. It says that integration of x square plus x minus 6 upon this is equal to something, right? So again, this is your partial fraction. If you want to do, you can do, or you can open the brackets and simplify the question. Choice is yours. Okay. So we'll go with partial fraction. But before that, why to go into partial fraction? If we have factors of the numerator, I can get the factors of the numerator as x plus 3x minus 2. You can open the brackets and check. You will get x squared plus 3x minus 2x, which is x, and 3 2s are minus 6. Upon x minus 2, x minus 1. X minus 2 gets cancelled. We have x plus 3 upon x minus 1. What is the rule of integration? If the degree of numerator and degree of denominators are same, try to bring numerator as same as denominator. What do I mean by this? I will write numerator as x minus 1 plus 4 upon x minus 1. So we try to bring the numerator same to same as denominator. Then we'll split the question into two parts. So we'll have this x minus 1 upon x minus 1 plus 4 upon x minus 1. X minus 1 gets cancelled. You are left out with 1. Integration of 1 will be x. 4 being constant, it will come out. Integration of 1 upon x will be log mod x minus 1 plus c. And this is your required answer. 4 log mod x minus 1. So no need of doing partial fraction, no need of doing completing the square. Straight away find the factors of numerator and simplify the sum. So that's your question number 2, which is x plus 4 log mod x minus 1 plus c. Now, maybe my answer looks like a bracket part. It should be a modulus part. Okay. Whenever you write answers of log, always please write that into modulus. We go on to the next one, question number 3. F dash x is equal to 1 upon x plus x. F of 1 is 5 by 2. What is f of x equal to? Right. Now we know that f of x is nothing but integration of f dash x plus c. Right. So you can write this way also, or you can write f of x is equal to integral part, whatever, however you want to solve. So f of x is equal to integration of f dash x, which is equal to integration of 1 by x plus x, which will be log mod x plus x square by 2 plus c. Now understand that this would be my answer for the given question had they not given me the values of f of 1. Since they have given me f of 1 value, I need to substitute. So after this, I substitute x is equal to 1. So f of 1 is equal to log mod 1, which is log 1, plus 1 by 2 plus c. The value given of f of 1 in the question is 5 by 2. Log 1 is always 0. 1 by 2 plus c. 5 by 2 minus 1 by 2, that will give you 4 by 2. So therefore, your value of c comes as 2. So value of c is 2. So my final answer of f of x will be plus 2 at the end. Do not write plus c. Understand? If you write plus c, it means that you do not know the function value. But here they had given this part. Had they not given this part, the answer would have been plus c. But since they have given you this part, my value of c will be replaced by 2. So final answer will have plus 2. Right? Okay, that's the third question. We go on to the fourth one. Find the value of 1 plus log x upon x with the proper substitution. Now, we don't have to find the value. We just need to find the proper substitution. And as I said, the substitution should be such that the derivative of that substitution should be in the question and go away along with dx. All right. So if I take, suppose, for example, 1 is equal to 2. 1 is equal to t. That is, I do the substitution this way. It goes wrong. Okay. I substitute log x is equal to t. 1 upon x dx is dt. This is still correct because we have the substitution. We have the derivative also. But the proper substitution is whenever we have a constant along with log, we always prefer that because when you take the derivative, the constant is still 0. The derivative of constant is 0. So it doesn't matter. Still your answer would be same. So proper substitution will be 1 plus log x equal to t. But this question, if it is suppose, for example, a 3-marker question or 4-marker question or somewhere there, you can still solve the sum by taking log x is equal to t. That is not a problem. Okay. But as per the fill in the blanks, the proper substitution, the logical substitution here should be 1 plus log x. That's the question number 4. Question number 5, you have to find the value of p in this. I will just zoom in the part. 1 upon x cube log x raised to x square is the question, and you need to find the value of the right hand side, and in that also you have to find the value of p. Okay, so now we have the question. I can write the question as x log x the whole square upon 1 by x cube. I can open the brackets, so it will become x square log x the whole square. Log x square will remain along with only 1x. So I write this as log x square into 1 upon x dx. And if you remember the property of integration, I'm using that property, using integration property. F of x raised to n into f dash x is equal to function raised to n plus 1 upon n plus 1 plus c. The first property, log x, the derivative is 1 upon x. So we have function and the derivative. Whatever is raised to power, that gets added to the answer. So my final answer as per this property will be log x raised to 3 upon 3 plus c. So when I compare this with my given right-hand side, log x cube is there and p becomes my 1 by 3. So my answer is p is equal to 1 by 3. So here we have used the property f of x raised to n into f dash x, the first property of integration chapter. Right, so this is the property, this is the fill in the blanks, question number 5. So this were the 5 answers. You can take a screenshot if you have not written anywhere. These are the 5 answers. I think so the third answer as per the given textbook is wrong because they have written something like plus C. Maybe do check that. But your correct answer should be plus 2 in that case. Right, so those are the 5 fill in the blanks. Then we move on to true or false. So true or false. The proper substitution for the given question is x raised to x is equal to t. Right? Now we have to check whether it is true or false. So let's understand that part. If you understand this, the substitution, what they have done, I will just zoom in the question so you will understand this. Right? Now this means that it is nothing but x raised to x. It is x raised to x square. Law of indices says that if you remember, a raised to m into n is equal to a raised to m into n. So x into x will become x square. So as per the given question, if I understand the question, it is x square 2 log x plus 1. Right? This is the simplified form. Right? It cannot be more simplified. So this is the simplified form. Now the question says that what if I have taken this substitution? Is it correct or not? So what is the rule of substitution? I take that term as t whose derivative will go away along with dx. So we need to check what happens if I take x raised to x square as t. Right? Now we know that function raised to function is solved using log only. So we take logarithms on both the side. So I will have first step something like this, taking log on both the side. X square will come down and it will be x square into log x is equal to log t. Right? We have to take the derivative. So we'll take u into v in this. So we'll have x square u into v. Log x is 1 upon x plus log x into x square is 2x. 1 upon t dt upon dx. 1x gets cancelled. So you are left out with x plus 2x log x. T into dx is equal to dt. Now please understand carefully what happens here. I take x common. 1 plus 2 log x. T was my x raised to 2 dx. And you observe that the entire question now becomes equal to dt. So my substitution is correct. Right? So my answer for this true or false is true because this substitution gives me the derivative which is already there in my question and which goes away along with my function dx. Right? So the first answer becomes true in that case. Right? I'll just show you that part. So this is what we have, the derivative part. Right? So we have to prove this part. We have to prove for ourselves. We just have to write true or false along with the statement. So the answer comes as true for this question. The second one. X into e raised to 2x is equal to e raised to 2x function plus c, where c is constant, then function is 2x minus 1 upon 2. Right? Let's see the question and simplify that question. Answer whatever it may be, that's okay. We'll see that part later. Function is what? So what he's saying, the question is, if you have this question, the integration answer comes as e raised to 2x minus 1 upon 2 plus c. Now we know that x into e raised to 2x is nothing but u into v. Still, someone will say that, sir, can we substitute 2x as t? Right? Why not? You can substitute 2x as t, but it will not help you any which ways. Right? Had it been 2x square, then my derivative would have gone as x dx or something like that. Right? So here it is not of any use of doing any substitution. We can directly start u into v. So as per the Ley rule, algebraic into exponential. So if I expand this, what will happen? X integral of e raised to 2x minus derivative of x integration of e raised to 2x the whole t. What will my answer? X into e raised to 2x upon 2. Right now, my answer stops here only, or I stop here only because I know that my answer will not match to my given answer. Right? But still, we solve that part and let's check that part. So derivative will be 1, e raised to 2x, chain rule, 2x. So that will be final answer, e raised to x upon 2 minus e raised to 2x upon 4 plus c. Right? Now, as per the given question, I will take e raised to 2x common and 2 common. So in the brackets, what do we get? E raised to 2x common upon 2. So we'll get 2x minus 1 plus c. Are we getting the same answer as the given part? What does it say? E raised to 2x upon 2 minus we take common. So we have half minus. Okay. So is this the same answer what is given in the question? Right? So you need to understand that this term is equal to this part. Okay, this term is equal to this part where f of x is nothing but 2x minus 1 upon 2. Right? Plus c will not come common. That's okay. Plus c will go outside. Right? That is not a problem. This is plus c. Right? Rest all is same. Right? So please understand as per the given question. Okay, I will just verify that again so that you are clear about this part. I will write this as e raised to 2x upon 2 into 2 plus 2x minus 1 e raised to 2x into 2 upon 2. Right? So you have e raised to 2x plus 2x into e raised to 2x minus e raised to 2x. You get the value as 2x into e raised to 2x. Right? What is happening here is, have we taken something wrong, some LCM part wrong here, so that we'll understand this part upon 2. I have taken common as upon 2, but logically it should be upon 4. Right? Because we have taken the LCM. We have taken the LCM x into e raised to 2x into 2 minus e raised to 2x the whole divided by 4. Right. So we verified that part. The division part should have been 4. And because of that 4 part, our answer becomes false. Right. So the second question is nothing but false because of this 2, which should have been 4 in the denominator. The third question. X into f of x is equal to f of x upon 2. Then f of x is equal to e raised to x squared. So what is your original question? Looks like x into e raised to x square is equal to answer e raised to x square upon 2. Right? Your function is this. So let's check that part. We'll solve that question. Right? So integration of x into ex square. We'll substitute x square as t. The derivative will be 2x, which will be x dx equal to half dt. So question will look like half integration of x has gone with dx, e raised to x square will become e raised to t dt, which is half e raised to t plus c. Half e raised to t is nothing but e raised to x square. So your f of x becomes e raised to x square by 2, which is 2. Right? So it matches the answer. Okay. So your answer for the third one becomes half e raised to x square, and e raised to x square is my function. Fourth question. X minus 1 upon x plus 1 into x minus 2. You have to find the partial fraction, say a and b's value, and then you have to prove that or check that whether a plus b is equal to 1 or not. Okay, so let's check that part. The first step will be x minus 1 is equal to a. I will write the entire term. X plus 1, x minus 2, a upon x plus 1, b upon x minus 2. I take the LCM, a into x minus 2 plus b into x plus 1. I substitute x is equal to minus 1 and x is equal to plus 2. If I substitute -1 in this, it will become left hand side -2 equal to a minus 3. So the value of a comes as 2/3. When I substitute 2 in place of x, I will get left hand side as 1 and the right hand side as 3b. So b is equal to 1/3. And when I add this two values, 2/3 plus 1/3 will be equal to 3/3, which is 1. That means this statement is true. So my answer for the fourth one comes as true, right? So your value of A came as 2/3 and your B answer came as 1/3. The addition gave you 3/3, which is equal to 1. So the statement given is true. We go on to the last one, fifth one. X minus 1 upon x plus 1 the whole cube e raised to x, and the function is x plus 1 the whole square, right? So this is your property sum. So let's check that. How do we solve this? First step will be e raised to x. E the whole square minus 2 upon x plus 1 the whole cube. This is the property e raised to x function plus derivative of that, which is equal to e raised to function plus c. So here my answer will be e raised to x upon x plus 1 the whole square plus c. Right? Now this would be my answer, but here the function f of x is not x plus 1 the whole square. My function f of x here in this sum is 1 upon x plus 1 the whole square. Right? And because of that reason, my answer comes as false. Right? F of x is not x plus 1 the whole square. F of x is 1 upon x plus 1 the whole square. And because of that answer, my value comes as false for this particular question. Right? So this is what we have in integration part. I think so. This was the last question, right? This was the true and false. If you want, you can take the screenshot. The first one true, second false, third, fourth true, and the last one was false of the chapter of integration. If you have any doubts, if you have not understood any of the questions, please let me know. Before coming for definite integration, please revise the chapter because the MCQs are very easy. Go through all the properties so that you have a bit of idea about the properties of definite integration. Right? Okay. Those who are done can leave. Those who have doubts, please ask me. Sir, can you repeat the sum, please? Labdi, which question you want? Can you tell me which question? The last sum? Last sum. Okay. Not true or false. The last sum of objective. The 10th one. Achha, last of true or false. Okay. Okay. So sorry. Last of true or false. Okay. Labdi, last one true or false. Our answer comes as false because when I use the property f of x plus f dash x, my answer becomes e raised to x function. Okay. Function is what? The first term what we have taken. This was my f of x plus of minus. This is my f dash x. So when I say what is my f of x, it is not x plus 1 the whole square. My f of x is 1 upon x plus 1 the whole square. And because of that reason, my answer comes as false. Right? Clear, Labdi? Okay, welcome. Hriday, sir, can you explain the concept of substitution, how to determine what to take t? See, always remember, Hriday, you take that term as t whose derivative is present in the question and it will go away along with dx. Now, what do I mean by this? Understand. For example, if I give you a random question, integration of log x upon x, right? So here my substitution will be log x as t because the derivative of log x will be 1 upon x, right? So my substitution will be log x is equal to t. I take the derivative. This will go away and become dt. So this will become dt. This will become t. So you take that term as t whose derivative will go along with dx. Chalo. Had the question been 1 upon x log x, still my substitution would have been log x only. Right? Because 1 upon x derivative will not give you log x. But log x ka derivative will give you 1 upon x. Okay, so here I can use the property also, f dash x upon f of x. I can use this property also and get the answer straight away, log of denominator plus. Right, so this is the part. Okay, are we clear with that?
The fourth sum of true and false.
Fourth sum of true and false. One second. Fourth sum of true and false is this one, this one, this one. Yeah. Fourth sum of true and false. See, here I have solved fourth sum of true or false. We use partial fraction and we'll get the values of a and b by the substitution method. Right? We substituted x is equal to -1. We got a value as 2 by 3.
This answer is of ax minus 2, but the question is a into x plus 1.
The question is a into x plus 1. One second, huh? X plus 1, x minus 2. Huh? The
We
answer
have to do opposite now. We have to take a upon x minus 2 plus b upon x plus 1.
Dear, understand. They have given the answer of the integration. We haven't solved the integration part. If I substitute a as 2 by 3, and it will be x plus 1, that will become 2 by 3 log mod x plus 1 only, which is this part, along with a. Right? And the integration of b will be b log mod x minus 2 after you get the value of b, which was 1 by 3. Did you get that?
No, sir.
See, you are comparing a with the given denominator. Don't check denominator. They have written the answer in terms of log. But they have solved integration part. We are not solving integration part because we just wanted a plus b 1 हो रहा है या नहीं हो रहा है. So once I get a as 2 by 3, once I get b as 1 by 3, I just add those two values. And if it becomes 1, then our true or false is done.
Okay, sir.
Still you have doubt, Kriyansh?
No, sir.
Clear, Kriyansh? For sure? Right?
Kind
of नहीं
No.
भाई, खत्म करो, बोलो क्या हो गया? What is your doubt? Tell me, what is your doubt? What is the problem? Do you have problem कि A का answer is not 2 by 3, B का answer is not 1 by 3?
Yeah. In question, we have
See.
a log
Question
x,
is this much only. How will you solve this? Tell me, what will be your first step, Kriyansh?
a upon x plus 1 plus
B upon
b
X
upon
minus,
x
correct?
minus.
So don't see the right hand side. I have solved this part. A upon X plus 1 as per your saying and B upon X minus 2. Is my LCM correct of the right hand side? A will get X minus 2 and B will get X plus 1.
Yes.
Okay. Now to get the value of A, will I substitute B as -1? That is X as -1. So that the B bracket becomes 0.
Yes, x minus 2.
X, I will substitute. X is equal to -1. So that this bracket becomes 0 and I get A ka value. Right? Then I substitute X is equal to 2 so that A becomes 0 or the part of A becomes 0 and we get B ka value.
Yes.
ठीक है, यहाँ तक clear है? Okay, now what is A plus B? Is it equal to 1 or not?
It is.
It is. So my answer will be true.
Yes.
Now your confusion comes that sir right hand side में तो A के साथ log mod x plus 1 दिया हुआ है. Now you understand that after this step, once I get A and B value, I will be solving this as 2 by 3, 1 upon x plus 1, plus 1 by 3, 1 upon x minus 2. So that will be 2 by 3 log mod x plus 1 plus 1 by 3 log mod x minus 2 plus c. So now A and B is still same and you have the respective answers.
Got it.
Got it? Okay.
Yes. Thank you,
Yes.
sir.
Welcome. Right? Anyone else has any doubt? Else we end the session. Right? This is what we have in integration. That is indefinite integration. Tomorrow we'll be doing the definite integration part. Okay, so please revise the formulas and everything so that you understand that easily. Till then, take care. Bye bye. See you tomorrow.